Hello, everybody. Welcome to this talk about from legacy to cloud. My name is Roland Huss. I'm a software engineer working for Red Hat. I'm the tech lead for a project called Synthesis and Fuse Online. But today I want to talk about something completely different. But before I start, just a disclaimer. So I'm giving this talk the second time, and the first time after the talk was finished, I got some feedback that people might expect some kind of a silver bullet, how they can do the migration for all of their projects. This talk it's not a silver bullet, it's just a experience about a small web application. It's for sure bigger than a Hello World application, but it's just big enough to fit into a presentation. So just to set the expectations right. So what this application is about. So actually there was some time ago, to be concrete, it was 30 years ago, and like you, I did also my high school graduation, or most of you. And then after this graduation, of course, from time to time, we had some kind of a class reunion. In our case, it was for every 5 years. And it was, again, my job to organize all these kind of class reunion meetings. And of course, the biggest challenge is to collect all the contacts, so to stay in contact with your people. So actually, you can imagine in 88, there were no email for everybody. So actually, I had one, but this was only me. So the first times we always collected the addresses all manually, but then as time goes on, we did it via email, and then in 2008 I started to write. I had some kind of a spare time, some free time, which was a rare occasion at the time, and I could write some kind of web application, which we see in a second. And this was a version which was running on bare metal, so it was running on a computer which was dedicated by my employer at the time. Then time moves on again, and then I've written something about Docker, talking about Docker, talking about Kubernetes. I started at Red Hat 3 years ago, and then I decided, okay, now it might be time really also to move away, of course, the application from my former employer, and to modernize it. And that's what the idea of this talk. And finally, I ported it now in 2018 to Kubernetes. And yeah, how does this application look like, which I'm going to show you. So I have here some small demo, which is takes maybe, I hope it's, let me just make a full screen then. Yeah, so actually this is so it's all in German, but it doesn't matter because it's, so you have a login screen, so you can register on your own. You can add your contact data, like your email address, of course, is the most important part. You can add some kind of password, and there you already see some sort of a map. So this map currently is showing my old school. But if you enter then the address data, which should happen now in a second, then you will see that it gets really located directly onto this location. So you enter the names, of course, and then here's the address, the street, and then the city afterwards. And as soon as you have finished, then I think the country over there. So actually, this is the address of the former conference where I've given the talk the first time. You have a focus now automatically to this part. You can simply take the marker, put it into the entry thing where you want, and then the location is stored as well along with your data. Like here. Then okay, then you just save. You are connected then, and then you can see all the other guys which has been already registered. Here's the event like that. So we also organize the events directly with the application, and you can just enter whether you will come to the event or whether not, and with how many people. So maybe you do not come, don't come, and then you know also again who is coming. So this is just not the real names to show you, but you see exactly who is already there. So actually I wanted to show with this short demo is just that it's not a trivial application. So you see, the technology behind this, you see that this Gmap integration, you see all the locations of all the other guys there, and you have also this blue spot actually is really the center of every of these locations. So maybe we should do the next event at that point. But maybe we should just skip the rest of this. It's just to show you that it's non-trivial. So you have also some kind of a gallery. This is important later because it has some pictures. You can upload pictures from the former life. So there's a forum here as well. And let's check the gallery, and then we stop the video. I hope it's there. yeah, so you have pictures from all the years, and then you can see just one nice picture for how the buses looked like in the year 87. So this was how it was at the time. Okay, sorry. Just stop here. And let's go. Sorry, I have to just up. I go reload. Present again. Okay, sorry. Okay, this is the architecture of the application we are going to migrate. So we have several parts, some kind of domains. We have a way to send mails directly from the application. We have a form, we have maps, we have pictures, events, we have something to store in a file system. These are for the pictures. We have a database in the background. And then we use also external services, like this map service from Google Maps and Gmaps, and then also a mail service, of course, for sending the mail. What was the tech stack in 2008? So actually there was Java 1.6 was the actual Java version, and the application is running on Java 1.6. We had, as a front-end technology, was used Wicked. So Wicked was something which was a nice alternative to JSF at the time. Spring 2.0 still, and Hibernate 3.2. And yeah, when I'm going now to move this into a cloud platform, of course I have two choices. I can either keep trying to keep the stack as it is, so that using all the old technologies, or I'm trying to update the tech stack, so like upgrading the Java version or not. So both of these approaches have advantages and disadvantages. The most advantage to keep it is, of course, that it's simple, because you don't have to do anything except just putting in, you just have to find still some kind of a 1.6 Java image, which actually really still exists. One problem is, of course, that all of these softwares are end of life. The versions are end of life. You do not find a lot of documentation anymore. When you search on Stack Overflow or on Google, typically you probably, if you have a problem, you do not get much help anymore. Then the one big issue is, of course, that you do not have any security fixes. So if it's a web application which is facing to the outside, and if you have a severe security hole in, for example, in Java 1.6, it does not get fixed. So this is really a bigger problem. Another more or less problem is that this Gmap component, which uses Gmap at that time, which was version 2, is nowadays at version 3, and this was not completely broken, but it also didn't really work well with the newest version. So if external dependencies changes, then you probably need to update your application as well. And the next final part is, of course, if you do not do the update now, you probably have an issue later on if you really are forced to do an update. So this might be a problem. So if you do the update, you have more work. And so I decided to go a path which is somewhat in between. So I did an update, but I did not an update to the latest version, but just to the version that I get it running there. And my main motivations were to get to Java 1.8, which is still supported, hopefully, okay, not so long anymore, but still I have this would be the first step, and to get the Gmap integration fixed. So this is now the first demo, how I ran it locally. Oops, sorry. Oh, doesn't matter. So, okay. So actually, there's a folder historical, and of course, I said I had MySQL at the background, so I start just a MySQL server directly on my notebook, and then I go into the Jetty folder and start it. So I already running here with Java 1.8. You see? Can I make it a little bit larger? Oh, sorry. It's not so easy, but no, damn it. Okay. I'm here. Now let's run it. Jetty run. And then, of course, it starts up. Oops, there's some kind of an error. Let's check what this is. And nice stack trace. Okay, you see, okay. annotation transaction attribute is only available in Java 1.5 or higher. So this is a really strange error message, of course, because I'm running on Java 8. Let's try the same thing with maybe with Java 7. So it's not so easy to type. Yeah, no, come on. 7 set up. So I have now Java 7 and try this again. Yeah, and actually everything works nicely. So it looks like that the application, if you upgrade just the Java version, does not work anymore because Java 1.8 is maybe not really good, well supported. And yeah, there's really a reason for this. And not from the beginning, just continue there. The reason, so this is the error we just have seen. And the problem is actually Spring 2.0. Because this is the way how Spring does the detection of the Java version. So this is really a static method initializer, which is called at the beginning, just to check whether it has annotation support or not. And you see that all the ifs only go up to 1.7, and it doesn't find any of these kind of version string in the Java version, then it falls back to 1.3. So actually, if you use Java 8, Spring 2.0, and by the way, Spring 2.5 as well, think about that it's running without annotation support. So what we have to do when we are updating to Java 1.8, we also have to upgrade Spring, of course, otherwise. So this is one also, so you see this is a common theme. So if you start to update something, it really tends to affect a lot of other parts of your system, and you need to do a lot of other updates things. Okay, so this is where I ended up. So I wanted to update to Java 8. So I actually updated to Spring 3.2. It's also not the latest one, but because I just wanted to the next version, which is just supported by Spring 8. I had to update this Google Maps API from 2 to 3. And actually then I also had to update Wicked for this reason, because Wicked 1.4 obviously does not have any support for GMap 3, so I had to update Wicked as well through 6.0. And yeah, for Jetty, of course, for the runtime, I just go to the latest one, because this was really not problematic. So going from Jetty 6 to 9 is a no-brainer, and the same is the same for MySQL. And actually, it took me quite some time to do this kind of migration, actually. So for Spring 3.2, it was not really that big, because it just was to find out what kind of dependencies are required, because the move from 2.0 to 3.2, so in 2.0 there was just a huge Spring.jar, which you used with contained every support from Spring, but then they moved to a more fine-granular approach to have separate jar files for that. The most work really was Wicked 6.0, especially also because I lost all my knowledge about Wicked at the time. And so I had to revisit all the stuff. And the first one, so also finding that the migration from 1.4 to 1.5 was much, much harder than from 1.5 to 6.0. And I suppose that then the migration to 7, which will be even as easy as the migration to 6 then. One problem there is that some of the components are not supported anymore. And for example, for this kind of gallery thing, you have a Lightbox JavaScript component, and this was completely gone. And I had to really to backport or to upgrade this as well. So I had to pick all the components and make them working for the current version. And then I tried also to go to generics, which is, yeah, you know, Wicked 6 has support for generics, which means that all your models, your internal models, can be specified in a type-safe way. But don't do this, because it's really, if you start at one point and you try to generify something, then it goes through your whole application, and you probably waste a lot of time. And as I do not want really to improve on this application, but just to migrate it and to keep the functionality, there's no real benefit in going to a type approach like for generics. Then, as I said, the Hibernate component, this was no problem at all, and also surprisingly, I didn't upgrade. The Jetty and MySQL components were easy to upgrade, and I didn't upgrade Hibernate at all. So this works still nicely. So Hibernate was a really good citizen when it comes to the new world. Okay, this was a part about the migration thing. So now we have our application. We have updated all this stuff. Took us some time, but now let's go really to the the cloud at the thing. And here, no. Before we do this, I just forgot this part, which actually was also some kind of a challenge. This was the way how I did configuration at the time. At the time, I really thought it was a very clever way how to do this, because I had some kind of Spring Bean, which I called a host selector. And this host selector had a kind of a configuration where the keys are host names or IP addresses, and then a reference to a very specific configuration object which is specific for this IP address. And then when this bean starts up, the code looks like this, where you have, just goes over all the addresses it can find locally, like get host address, and request the server name from the HTTP request, and so on and so forth. And if as soon as it finds some kind of a key with this IP address, it picked up this configuration. So it was quite nice. So I stuffed everything, every configuration on every environment, from my home local desktop machine to the production thing where it's running, into the same application. It was also encapsulated into the WAR file. And with the 12-factor app manifesto, we all know this is bad. So you should always externalize your configuration. And I now know why, because it's really in the cloud world, IP address is not constant. So it always changes. You have no idea where your code is running at the end. So this was a bad thing. So I changed everything, of course, now to use environment variables. And this I can really specify from the outside when I'm creating my application. This was also a bit of a mess there, but a challenge for me in that case. Okay, but now we are coming to the next steps. And as promised, so we first now start with putting all our application into a container. In that case, in a Docker container. Then next step then is to move everything to Kubernetes, and then I have an additional step where I show you how we can put this even on OpenShift, which is a kind of enterprise distribution for Kubernetes. Okay, let's get started. So here's the architecture for the containerization. Has just two images. So one is the application itself. It's then contained including the chatty in a Docker image. Then we have an image for MySQL, which is just the stock image coming from Docker Hub. And both of them are accessing a volume where the database stores its data and where the pictures are stored. And to run it, I use Docker Compose to fire up everything together. So let's try this. So now a little bit. Okay. Here is still our application. I'm just stopping the MySQL server here. Okay. So what I have to do to put my WAR file into a Docker image, and you probably already, so I haven't told it, but I'm using Maven as a build tool. And all what I have to do now to make a container out of my chatty and my web application, I have to specify a plugin to my Maven build, which is the Docker-Maven plugin in that case. And then this is one part which I have to do. And the next step is I just put in a Docker file on the same level like the pom.xml, which looks like this. So I'm using the base chatty. I'm switching to root. And afterwards, I have to install some extra components, which is used for scaling images. As I said, you can upload images there. And to have that everything of these images has the same format, I'm using ImageMagick, which is some tool for scaling images. Switch back to the user chatty, and then I can use in this Docker file also properties which are known to Maven. So actually here I'm really referring to the WAR file which is built and can add this to the container. So let's see how this goes. So what I'm doing here now is Maven package Docker build. So I have a Docker daemon running in the background. And actually, if the base image, the chatty, wouldn't be already in the Docker daemon, it would download it from Docker Hub. I build it, and there you see that so it goes very quickly because I already tried this before. And the next thing, let's have a look in the Docker Compose file to run the whole stuff. So you have here Docker Compose. As I said, you have all this kind of environment variables which you set. So I'm referring here to really environment variables which I already have set into my shell. These are set for the container when it's created from the image. Here's the reference to the name of the image. So this is actually, I haven't specified in the pom.xml, so if I don't do it, it's just calculated from the Maven coordinates. Then I have a volume for the picture part, which is here. And then I have a second interface, second container created named db, which is based on the MySQL data image. And it's also mounting a volume here for my laptop. And then I have here this link. So with this link in thing. There's a network link created between both containers, and the container DB is then seen within the in the web application container under the hostname DB. So I can directly refer to the database with the service name. So that's all what's done with Docker Compose, and all I have to do now is to call Docker Compose up. So this is just because I haven't shut down previously cleanly. So first of all, the database has been started, and then the application is started. And as you have seen here in the Docker Compose file, I also mapped the port here from 8080 to 8080. So when I go now to my browser, and call localhost 8080, then I should see my application like it is. So this was really easy. So actually, really to get your application in the container, this is a no-brainer. And yeah, so but now let's go to the next step. So yeah, before I do so, just a quick summary of this Docker-Maven plugin I just shown you. This was what I've shown you was the so-called simple Docker file modus, which means it's really super easy to use if you have only a Docker file and you just need to package up your application. If you need more, you can do so by adding some configuration. So you can use an XML configuration within the plugin. You could use still Docker files. You could even put Docker Compose files somewhere else so that you, when you call Maven Docker run, then the Docker Compose file is used to start up like I did just before. You can even specify to create multiple images. You have a very comprehensive authentication support for various registries. So you can push the image as well to a registry like to Docker Hub, but also to AWS. And there are a lot of tons, so you can read the manual, which is quite lengthy. If you like to, so it's quite powerful, and yeah, it's also used quite a lot for us. So we are using it quite a lot. Sorry. Okay, now the next step is to Kubernetes. So Kubernetes, just in a nutshell, for those who never heard about Kubernetes, I hope that are not so many, because so Kubernetes is an open source project created in 2014 by Google. And it actually encapsulates all the experience that they collected with their internal framework, which was called Borg, and it's still called Borg. So they did not really open source their internal framework, but they just created a new one with the lessons learned from their existing system. And it's an orchestration platform for containers, which means it's the task of Kubernetes is to schedule your containers over a whole fleet of nodes. So you have a cluster, you have multiple machines where your containers are running, and the task of Kubernetes is to take care about the scheduling. So you give Kubernetes a container, and it just selects one of these nodes and run this container. It's easy to scale horizontally your application by just providing some kind of parameter so that you have multiple copies of your application running. Kubernetes has self-healing features, which means that this comes together with the declarative nature of Kubernetes. So you declare always some kind of a target state, and Kubernetes checks the current state and tries to reach this target state. For example, you describe what kind of pods should be running and how many, let's say 3, and then Kubernetes periodically checks whether there are really 3 pods or containers are running. And if there are only 2, then Kubernetes will start a new one and try to reconcile to the current state. By the way, when I say pod, it's just a kind of abstraction on top of containers. So a pod can be 1 or more containers, but this is the basic atom in Kubernetes. Then it has several advanced features like service discovery, so that the services can find each other, like, for example, for Docker Compose, that each service has a name, and this name is also can be looked up by DNS within the Kubernetes cluster. It has support for installation and updates, like rollouts and rollbacks, so you can also describe the kind of update strategy you want to have, whether you want to have rolling updates where you have a zero downtime scenario, all that. And of course, many more features. The architecture is quite easy, so you have a master server. This provides a REST API to the outside, which you can access with kube control, which is a command line tool. And then the master is responsible to contact the node, so there's a Kubernetes so-called kubelet running on each of these nodes. They are communicating in a bidirectional way with the master to report the status, and the master just says, here's a container, just deploy it there. And yeah, current version is 1.10, and of course, yeah, that's it. So if you have the chance to try out Kubernetes, or maybe even using Kubernetes, I really highly recommend to look into this, because I think this will be the future, or is already the way how we deploy containers in the cloud. The next choice I had to make is, of course, I want to operate this, and I can, of course, use some kind of Kubernetes cloud out there. There are a lot of, every cloud provider has already a managed Kubernetes cluster, so you can just order a cluster and can use it. But another constraint for me is that it has to be cheap, very cheap, because you know this is very long running, and I hope that it's running also for the next 10 years, I hope so. So I checked all the hosting options which I have, so you hear some kind of a conversation. This was valid in February or March. And you see that the hosted offerings like Kubernetes Engine or Azure Container Service, they're all around 15 euros per month, though it's more, really over my budget. You could also OpenShift Online Pro. As I said, OpenShift is an offering from Red Hat, which is an enterprise, provides enterprise features, which I probably do not know and do not need actually for my application. But there's also an OpenShift Online Starter tier, which is for free. This is very attractive for me, of course, because it's nothing is cheaper than free. And yeah, but at the moment, I just started with really some kind of a virtual machine, so a so-called single node cluster, which I used, and I checked DigitalOcean, and then ended up at Scaleway. So I'm using Scaleway, which, by the way, if you don't know it, it's also a very awesome and inexpensive way to install your virtual machines. I just a short summary what I did. So I ordered one VM. I installed Kubernetes cluster with kubeadm, which is a tool by Kubernetes for easily installing a cluster. So you typically do a kubeadm on the master, kubeadm init, and then you get a token, and then you go to each of the other nodes and say kubeadm join with this token, and then it forms up a cluster. So it's very, of course, there are a lot of details which you can tune and to optimize, but this is a very easy way to install a cluster. I use Traffic as an ingress controller, so this is a very nice Go program which you can easily use because it supports already Let's Encrypt. I can add my own domain name there. This is quite nice. I used Mailgun as a SMTP service. Yeah, also a little nice story about this one. Because I used Mailgun, and Mailgun has also a free tier. Mailgun is some kind of service for bulk emails. And, but the free service has only shared IP addresses. So actually, they have a pool of IP addresses, and I get something by random. And when I send out a mail, then of course, it's not only me who are using these IP addresses, but all the spammers out there as well, so because it's a free tier. And then a lot of these IP addresses were blocked at the target mail service. So I lost a lot of mails there with Mailgun, so I've switched back to Google Mail. This had the disadvantage that the mail which I have sent just hadn't the domain which I used, so it's just coming from a Google Mail address. I did some monitoring, so actually it's estimated some cost of 200 euro for 5 years, and this is something which we can really use easily. Okay, so how does the orchestration look like now? So what we see here, these are 3 fundamental objects in Kubernetes. It's a pod. And for the first step, actually, it's something which I do not recommend, actually, but I just to getting running, I put the database and the application itself in the same pod. This has an advantage that they can easily share the data, like the volume, and but of course it does not scale. You cannot scale. You can have only one replica in that setup. For my use case, where I have only a single node cluster, this also works quite nicely for the beginning. But we will see in a second how we should do it in the real world. Then on top of the pod, you have a deployment. You have a service. So deployment is simply the entity which takes care about the life cycle of the pod, and the service exposes this the pod to the outside or within the cluster, and then you have again another object which is called ingress for exposing it to the outside world. Okay, let's have a quick look how this looks like. So now let's stop it here. That one. So actually, if you want to develop with Kubernetes, you can of course go into the cloud, like James just shown in the last session from him. But you can also use Minikube, which is I think also quite awesome one-node cluster which runs on your desktop, which actually encapsulates a Docker daemon inside, and it's just a single binary, say Minikube, start, stop, and so on. And then you have just a very experimental cluster. So no, I don't want to update now, please not. And as I said, you have then here a command which is called kube control, get pods, so there's nothing running locally. And what can I do to install now my container into this pod? So I just have to switch to the next branch. Okay, so let's go back to the POM XML for a second. So what we see here is now they have yet another plugin, which is called the Fabricate Maven plugin, which is more or less an extension on the Docker Maven plugin. And this allows you to create all these resource descriptors which are needed to deploy on Kubernetes. So Kubernetes, as I said, has a REST API. It's all about resources, and so you need to provide these resources there. And you can call it like this, and call here Maven Fabricate resource. So, perfect. Looks good. Oh yeah. Okay, perfect. Okay, so we are not using Maven Fabricate. Let's make it clean and then I'll use another one. No, doesn't work. So the demo gods are not with me. But no worries, I have already prepared these kind of resource descriptors, so we can easily use it. So you have here so the central part is this called of deployment. So if you haven't seen it yet, from Kubernetes, so you have always such a kind. You have a specification. You have your environment variables here, of course. And interesting thing is for Kubernetes that you have also some kind of indirection to secrets. So I do not put in the credentials for my SMTP host and user directly into the deployment descriptor, but delegate to a secret which is installed elsewhere. I create a service, as I said. So the service is just in front of the deployment, and the service selects here with labels my pod and exposes the port 8080 from the pod to the service at 8080. And then this service is only an internal service of the cluster, and now I need finally to expose it to the outside so that everybody can access it. Therefore, I have called an ingress, which is just connecting your service. You have here the service name, the service port, and then you can access it directly on the cluster from the outside. Let's apply this to the thing here. So we go to, we're already there, so let's go to Kubernetes here, and kube control create -f dot, so it creates all of these files. So K is just a shortcut for me, so K pods, and you see here that I'm really doing both pods in the same deployment. As I said, it's not really the true solution. If you jump back here, you see that I have here a specific list of containers. The first container is just here my image, and the second container is just here my MySQL. But as I said, don't do this at home. So hopefully, okay. I guess it's just describe deployment 88. So could be that it has to pull the things in the background. That's just to be sure. So you can also access the internal Docker daemon of that one, and I'm just trying to package that. But maybe we just leave it alone. So I'm here. Okay, I'm in the wrong directory. Now I have it. So actually, I'm still here in Java 7. This is probably also the reason why the other thing didn't work, because I'm still at Java 7, and then should have done it like this. Okay. So, and now let's just to be sure whether it's, oops, sorry, whether this fabricate resource works. Yeah, looks good. So actually, this was really the reason that I was still on Java 7 and not Java 8. But let's check our pod. No, it's still starting. So maybe let's just delete everything here. Maybe I did something wrong. Cube control, delete -f dot. So, and now let's try it with the plugin, because you also can apply directly with the plugin to the cluster, to the running one. Let's see whether this works better. No. Again in the wrong directory. So so the other one is, so you see that the other one, which I just stopped, is already stopping, but here this is a new one, which is running. And I can now just check this, I can use my Minikube IP. So as I said, it's running in a virtual machine. Use the name of the application, and then start up the route, and then normally it should just go to this IP address, and it's running. So this is the one which is running directly into the cluster. Okay, let's go on. No, don't want this one. Ah, sorry. Don't want this. And I just want, come on, full screen. No, doesn't like it. Okay, nevertheless, let's continue. Yeah, Fabricated Maven plugin, just as I said, it's an extension to the Docker Maven plugin. It creates all the Kubernetes, but also OpenShift descriptors. It focuses mostly on, so it's the upstream project to OpenShift.io. In case you already heard about OpenShift.io, it knows multiple configuration options. So one is the serial configuration option, which we just have seen. So we haven't added any configuration, but it created all the resource descriptors. You always also can, of course, put configuration into XML. And another part which is very powerful, which is resource fragments, where you can all set up various other parts of your application. It supports also support for debugging, so you can really directly debug within the Kubernetes cluster itself. So just by having a port forward into the cluster to the debug port of your application, and allows you to watch for changes on your local machine, and so that it gets some kind of redeployment. And if you would use something like Spring Boot with the dev tools enabled, then it also would do some kind of auto-hot reloading of your data within the container then. There. So this is quite nice. And sorry. Just continue. Yeah, no, it looks better. Yeah, but as I said, a simple port is too simplistic. Why? Of course, I think it's quite clear, because you couple the life cycle of the application, the database. So if there's an issue with the database, your whole application, of course, gets down, and you cannot even show some kind of error message. It's not scalable at all. And what I have done is I used a host path volume, which means it's just a directory on the node where the application is running on. And this obviously only works for a single node cluster, because if you, all these pods, so if a pod dies and comes up, it's just randomly running on any node, and it doesn't guarantee that your database volume is actually on the node where your pod is restarting. So what can we do then? So the next step is now really to separate both of them. So you have now two deployments, two services. You use so one deployment for the application itself, one for the database. And the database stores its data on a so-called persistent volume. And this persistent volume is available on every node. So you have to think about like a distributed file system, like NFS can be used for persistent volume. And this is a concept also provided by Kubernetes. So what you are doing as application, you are creating a persistent volume claim, which means I require so much data. And then I get, so then Kubernetes just knows this and mounts the persistent volume within the file system of your pod. And you can use this to store your data on it. I also switched now because I'm now trying really to target this OpenShift starter tier. So I'm trying really to move to OpenShift. So I'm using OpenShift specific concepts. One of this is called route. We have seen ingress is the object in the Kubernetes world. In the OpenShift world, it's called route, but it's actually more or less the same. And the route actually is the entry point to your service from the outside world, but we always only, of course, want to access our web application service and not the database service from the outside. Then you have the OpenShift router, which already comes with you. So I had to install on my Kubernetes cluster an ingress controller on my own. But for OpenShift, there already comes a router, which then goes to from the outside. Just a short introduction to OpenShift. I don't spend much time on this slide. So actually, what is OpenShift? I said it's an enterprise distribution of Kubernetes, but it adds also some extra features, like, for example, the build aspect to Kubernetes. So Kubernetes itself is only about running your containers, but not about building your images. And this is what OpenShift does with the so-called source-to-image technology. And you can build the images in the cluster as well. This has some advantages, of course, because you then also can automatically deploy after the build. And if, for example, some base image has some kind of a security issue, and you fix the base image, and if OpenShift already knows how everything is connected there, then it can recreate all the application images which are based on this base image, and then even can redeploy it into the cluster itself. So it's a quite easy, a simple way how you can ensure that everybody's on the same level. It has tons of extra infrastructure services out of the box. So if you install OpenShift, and by the way, there's also something like Minishift, which is the same thing like Minikube, but for OpenShift. You have a registry, you have a router, you have OAuth, single sign-on, you have multi-tenancy, which means you have really hard projects which are separated clearly. A very nice management UI, and in the newer version there are stuff like an Ansible Service Broker where you can install your application with so-called Ansible Service Bundles, which you just put into your in the cluster, and then there are some Ansible playbook is running to install all these objects there. Okay, as I said, OpenShift Online started here. If you're interested in OpenShift, just try it. It's for free, and there are some limits, of course. And so it's really very small. You have a very small budget for your applications, only 1 gigabyte for free, one persistent volume with 1 gigabyte. And the one subtle thing, which is maybe not so well known, is that in OpenShift Online you have a minimum memory request, which means that your application cannot be less than this. So actually, for example, if you would have some microservice which only might consume 20 megabytes, you still have to get 100 megabytes. So you can only run 10 microservices like this. But it's even worse because there's some kind of a limit request ratio. So limit requests are the ways like how in Kubernetes things can be controlled. And this is fixed to 50%, which means your application takes for sure 200 megabytes of memory. So you can get only 5 things into it. So just as a side note. What I wanted to show you, but actually I'm afraid I don't have enough time to show it to you, OpenShift templates, which is a nice way how you can install whole applications. So not only one single deployment, but also all the resource objects at once. So such a template knows about placeholders, which you fill in from the outside. And it's similar to Helm charts, which is the way how Kubernetes does application management, but it's just another technology. There are many already predefined templates which you can just use for OpenShift. And as I said, Ansible Playbooks is an alternative for that. So maybe, okay, I have 5 minutes, I tried. So, I know, so I just have to. So when you go to OpenShift, oh, come on, you see something like that. So you can have some entry point for the subscription. You can open the web console. Actually, I already did this here, hopefully. This looks like this. So you have here a lot of predefined templates, which you can just install a Node application base, a PostgreSQL. What I want to do, I'm just, so you can also, just check me, it's here, yeah, login command. I just create a project, it's called demo. No, okay, demo. So the project name needs to be unique over the whole OpenShift cluster, so actually it's quite clear the demo already is taken. Then I go to the console. I use here some kind of a login token to check in. So actually I hope that my project is created. So in the meantime, I'm going to show you this. Oh, I just show you the template. No fear. Okay. So what you see here is, So a template actually is also just an object. You have here template, and of course I put all my environment variables which I'm setting to the template parameters, which has to be fed from the outside. Be fed from the outside, exactly. And then we see all the deployment config like this, and actually it looks quite similar to the thing which we had previously. So now let's see whether the has been created. OC get project. So project is actually kind of a namespace. So this is also an abstraction introduced by OpenShift. Come on. No resources found. So actually, I'm not sure whether really on this one. Okay. OC new project, so you can easily create one, also from the command line. Let's call it 2. So I already have one. Okay, project. So this is the one I did from the UI. Minus demo. Okay. So sorry, but I can. No, it's called demo Abyss, so it's vice versa. Memory is really. You see, I'm really getting old. Now also project. Go into that. No. So it's not the fastest one, and I'm not sure whether it's the network or whether it's OpenShift Online itself. Come on. Come on. Okay. Maybe at the end then. Let's continue with the slides and finish up. Oh, we are here. I go into I have this directory, and then I can just call auth create. So I'm creating the template first, which is just another object. And then I can just apply this object to, so I can apply the object. I have to provide the parameters. And then all the objects which are created within, or which are defined in the template are just created. And if I go back to the console here, I go into my project, you see now how all of these things are coming up, and maybe at the end we can check whether it's really ran everything. Okay, let me finish up. So actually this is the point where I'm now at the moment, so where the application is running, but of course we can still continue there. It's not the end, so what we could do as well, just to split up our very monolithic app, say like this, into microservices, of course. And there you typically cut these microservices on domain boundaries, like for example the pictures. There could be a picture service for storing the pictures in the data on the file system, a forum service, a mail service. And so the forum service would have its own database for storing all the entries there, or the posts. And then you have maybe some servers which are much too small to make it an own microservice, because everything of this comes with some kind of a budget penalty, so you need some kind of memory for this. And so you can combine everything into, so there's like the map service, so more the UI-centric services are better kept together, because you cannot really nicely make components out of these UI parts. So of course, there are other ideas where you can even improve this. So you can introduce a so-called service mesh to make it even more resilient, like, for example, with a circuit breaker and so on. You can introduce tracing. Also, as I said, MySQL was always running as a single application, scale only 1 to 1. So maybe a good idea would be to run it in the cluster mode as well. So there are certain MySQL clusters which you could use and also put into the Kubernetes. And of course, the web application at the moment is not very scalable, because you have Wicked is very heavy session-based, so it keeps some state in the memory in the HTTP session. So you would need to introduce so-called session affinity, that if you have multiple copies of your application, that you can easily scale there. And what would be really interesting to know, whether I could also make components out of these. So Wicked is based on components, but these internal components would be nice that these components would also be served by the microservices themselves. Yeah, this is maybe some my task for the next 10 years. So when we meet again in 10 years, yeah, hopefully, then I might show you this or something completely different. Okay, so that's it. So I'm at the end. I hope I could show you through this small journey that it's really not difficult to get any application onto Kubernetes. I even tried this with Java 1.6, which worked also quite nicely. And use tools for doing these steps like Docker-Maven-PLUGIN, Fabricate-Maven-PLUGIN, and yeah, and try Kubernetes and OpenShift. So that's it. That's all I have. Oh no, one last thing. So this is the only plug I have. So I'm writing. My colleague is writing with me as a co-author a book about Kubernetes patterns, where you even see more patterns, for example, like doing configuration for applications and more. But now that's really it. And I thank you. I think we do not have any time for questions, or do we have? So we have one question, maybe? Someone? No? Okay, then thank you very much, and enjoy the rest of the conference. Thanks.